Assalamu alaikum class 8th. Welcome once again to the chemistry class. Let's quickly revise what all we had done in chapter 1, that is matter. We all know matter is anything that has mass and occupies space. Yes, we all know about this. And we know that matter is made up of very small particles which are very small and are called atoms. And this exhibits all the properties of matter and does not have an independent existence. So, an atom shows a unique characteristic of an element, right? So the smallest particle of matter that exhibits all the properties of matter and has an independent existence is called a molecule, right? Now we move on to the next point, that is the kinetic theory of matter, which has various postulates. Number 1, matter is made up of very small particles called atoms or molecules. Then we have point number 2, that is the constituent particles of a particular matter are identical in all respects. The particles of matter have spaces between them. These spaces are called interparticle or intermolecular spaces, or we can even call them voids. The particles of matter attract one another with a force called interparticle or intermolecular force of attraction. The particles of matter are in continuous random motion, which is also called Brownian motion. The particles of matter possess kinetic energy due to their continuous motion. Then, based on the kinetic theory, we can explain the states of matter. In solids, the particles, that is the molecules, are very closely packed and they possess least kinetic energy. There is a very strong intermolecular force of attraction and a negligible intermolecular space. Then we have in liquids, the particles are loosely packed. The particles of a liquid possess high kinetic energy. The intermolecular force of attraction in a liquid is weak and the intermolecular space is more than that in solids. Therefore, liquids have a definite volume but do not have a definite shape, whereas solids have a definite shape and volume. They are hard, rigid and incompressible, that is, they cannot be pressed into any desired shape. Then we move on to the gases. The particles are far apart and move freely in a random manner. They possess very high kinetic energy and the intermolecular force of attraction is very weak and intermolecular space is very large. As a result, they do not have a definite shape and volume, right? So we had the table 1.1 which you had to learn, which had the differences based on the arrangement of molecules, intermolecular force of attraction, intermolecular space, position of molecules, shape, volume, rigidity, fluidity, compressibility, kinetic energy and density of the 3 states of matter. Then I hope you have done the exercise that follows it, that is given on page number 9. Then we move on to the next page, that is the interconversion of states of matter, that is the process of change of matter from one physical state to another and back to the original state without any change in its chemical composition. This is called as interconversion of states of matter. This can be done by changing the temperature and changing the pressure. By changing the temperature, we can bring the different states, we can change the different states at different temperatures. So for this we had melting, the process during which a solid changes into a liquid state at a fixed temperature on heating. Then we had the fixed temperature at which a solid changes into its liquid state, which is called the melting point. Then boiling, the process during which a liquid changes into its gaseous state at a fixed temperature on heating. The fixed temperature at which a liquid changes into gaseous state is called the boiling point. Then the process during which a liquid changes into its vapor at temperature below the boiling point is called evaporation, and this boiling is an extreme form of evaporation. Condensation, the process during which a gas changes into its liquid state at a fixed temperature on cooling. The fixed temperature at which a gas changes into its liquid state is called its condensation point. The process during which a liquid changes into its solid state at a fixed temperature on cooling is called freezing. The fixed temperature at which a liquid changes into its solid state is called its freezing point. Then we have the sublimation. Some substances change directly from the solid state to the gaseous state, and vice versa, that is from the gaseous state to the solid state without undergoing the intermediate liquid state. The two processes are called sublimation and deposition respectively. How these changes take place, we have discussed this also, that the particles of a solid vibrate about the mean position. When a solid is heated, its constituent particles gain energy and start vibrating more vigorously. When we heat it further, they acquire more and more kinetic energy. At the melting point, the particles of a solid have sufficient kinetic energy to overcome the strong intermolecular force of attraction that holds them in a fixed position. The particles start moving and the substance in solid changes into liquid state. And if we further continue the heating, the particles acquire more kinetic energy, and at the boiling point, the particles of the liquid have sufficient kinetic energy to overcome the intermolecular force of attraction that binds the particles of the liquid. The particles become free to move in any direction, and the substance in liquid state changes into gaseous state. Similarly, when a substance in gaseous state is cooled, the constituent particles lose the kinetic energy, and at the condensation point, the intermolecular force of attraction increases and the intermolecular space decreases. The movement of the particle decreases and the substance in gaseous state changes into liquid state. On further cooling, the kinetic energy of the particle decreases further. At freezing point, the intermolecular force of attraction increases and the intermolecular space becomes negligible. Right? The particles do not move from their position and the substance in liquid state changes into the solid state. This is what is happening. Then next is by change of pressure we can change the state of matter. We had taken the example of the LPG that we are using in the kitchens, and this, when we open the valve of a regulator, the pressure is released, LPG comes out in the form of a gas. Another example was when we are liquefying the gases like oxygen and hydrogen. Then the law of conservation of mass, that is, mass can neither be created nor destroyed during a physical or chemical change, which we had shown by two activities. And then we had done the exercise on page number 13. I hope you have completed this exercise also, and you have completed all the question answers in your notebooks. All exercises that are given at the end of each portion in the form of fill in the blanks, match the following, etc. A one word answer have to be done in the book itself. Rest of the question answers, that is the exercises which are given on page number 14 and 15, have to be done in the notebooks. The diagrams which have to be drawn will be specified in the revision assignment which I give. Please do the revision assignment in your notebooks. Revise the chapter and you will be given the date of the assessment. Assalamu alaikum wa rahmatullahi wa barakatuhu.